Experimental research. Experimental research is the most rigorous of all research methods and is arguably the best method for testing cause and effect relationships. Causality. Causality suggests that a single event or the cause always leads to another single event or the effect. Anderson states, causes and consequences concentrate on the relationships between phenomena or how one phenomenon affects another. Next, we have here the conditions for causality. First, we have the necessary condition. Next, the sufficient condition. Next, we have the contributory condition. And we have also the contingent conditions. And lastly, we have the alternative condition. So let's have first the necessary condition. It is one that must occur if the phenomenon of which it is a cause is to occur. Next, we have the sufficient condition. It is one that is always followed by the phenomenon which it causes. Next, we have the contributory conditions. It increases the probability that a certain phenomenon will occur. Next, we have the contingent conditions. It is under which a given variable is a contributory cause. And lastly, we have the alternative conditions. It makes the occurrence of a certain phenomenon more likely. We have also the mechanism, which refers to the conditions that create the causal connection or the intervening variables. So next, we have here the basis for inferring causal relationships. First, we have the concomitant variation. Next, the time order of occurrence. And lastly, we have the non-spuriousness. So one type of evidence for inferring a causal relationship is known as concomitant variation. Evidence of concomitant variation or covariation is when there are two variables, indicates that the independent variable x and the dependent variable or assumed effect y are associated in the way predicted by the causal hypothesis. So the second basis for inferring a causal relationship between two variables relates to the time order of occurrence of the variables. So to establish the necessary time order requires evidence that the dependent variable did not occur before the independent variable. So the third basis for inferring a causal relationship is non-spuriousness, or evidence ruling out other factors as possible causes of the dependent variable. So in controlling the variables, we have the independent variable and dependent variable. So when we say independent variable, it is the experimental variable. It also referred to as the cause or causal variable and the predictor variable. And it is the variable that the researcher manipulates. Next, we have the dependent variable. It is often known as the effect, the subject variable, or the criterion variable. It is caused or at least affected by the independent variable. Next, we have the random assignment. So it is a procedure used after the sample is selected, but before the experimental treatment is applied. So random assignment is an experimental procedure of assigning participants to one of several conditions randomly. So it is also a way to control for possible confounds in the experiment and yield more valid results. So next, we have the internal validity and external validity. So when we say internal validity, it refers to the possibility that the conclusions drawn from experimental results may not accurately reflect what went on in the experiment itself. So when we say external validity, it is the extent to which one can generalize the results of the research to the populations and settings of interest in the hypothesis. Unfortunately, a number of factors can jeopardize the internal validity of experimental research. So first, we have the history or specific events, in addition to the experimental treatment of variable which occur between measurements of the dependent variable. Next, we have what we call maturation, or process within the subjects operating as a function of time, such as growing older or more mature. Next, we have testing, or the effects of taking a test upon the scores of a subsequent testing. Next, we have the instrumentation, or the process wherein changes in the techniques used for the measurements or changes in the persons making the measurements affect a second set of measurements or observations. Next, we have the statistical regression, or the statistical phenomenon wherein extreme scores obtained on a first test tend to gravitate toward the mean on subsequent tests. Next, we have biases in differential selection of subjects for the comparison groups. Next, we have the experimental mortality, or the differential loss of subjects from the comparison group. And lastly, we have the interaction of selection and other sources of invalidity. So next, we have also here the threats to external validity. So the major factors jeopardizing external validity includes the following. First, we have the reactive or interactive effect of testing. This occurs when a pretest increase or decrease the subject's sensitivity. So we have also here the threats to external validity. So the major factors jeopardizing external validity includes the following. First, we have the reactive or interactive effect of testing. Next, we have the interaction effects of selection biases and the experimental variable. Next, we have the reactive effects of the experimental arrangements that can prevent the researcher from being able to generalize about the effect of the experimental variable on persons exposed to it in non-experimental settings. And lastly, we have the multiple treatment interference may occur whenever more than one experimental treatment is applied to the same subjects, basically because the effects of prior treatments do not entirely disappear. So, the threats to external validity are basically interaction effects involving the experimental treatment and some other variable. Through experiments and correlational studies, true experiments can be conducted in real-life settings, assuming the controls are adequate, and correlational studies may well permit one to predict change in one variable based on knowledge about another variable, but it would not allow the establishment of a causal relationship between the variables. In evaluating the design and results of an experiment, there are several points that the researcher should consider. 1. The experiment should have the ability to test a null hypothesis, which suggests that there is no relationship between the variables being studied. 2. The experiment should be sensitive. And last but not the least, the significance or importance of the result should be considered. Difficulties to be avoided. So in order to design an experiment that will be as reliable and valid as possible, the researcher should attempt to avoid the following. 1. Relying too heavily on a single experiment. 2. Using poorly designed or faulty data collection instruments. 3. Not identifying all of the variables that may affect the results. 4. Not choosing subjects that are as representative of the population as possible. 5. Introducing experimenter bias. 6. Introducing subject bias. 7. Making the subjects aware of the hypothesis being tested through unconscious signaling or behavior. And lastly, using an insufficient number of subjects. So next, we have here the examples of true experimental designs. First, we have the pretest post-test control group design. 2. We have the Solomon 4 group design. 3. We have the post-test only control group design. And lastly, we have the factorial designs. So let's have first the pretest post-test control group design. So this experimental design is considered strong because it controls for all 8 of the threats to internal validity. So we have here the diagram for this design. So in this illustration, the X symbolizes the experimental treatment or independent variable or cause,
and the O represents the process of observation or measurement of the dependent variable. The R indicates that the subjects in the group, so designing 2. We have the Solomon 4 group design. So this design scores the same on interval validity. So as can be seen, this design involves 4 randomly assigned or equivalent groups, 2 of which receive the experimental treatment and 2 of which are given post-test only. 3. We have the post-test only control group design. So this design is not used as frequently as it deserves to be, perhaps because of its lack of a pre-test. So the post-test only control group design, the diagrams is the same as the last 2 groups of the Solomon 4 groups design. And 4, we have the factorial designs. So the 3 preceding designs are examples of designs capable of accommodating only one independent and one dependent variable. So factorial designs can deal with 2 or more independent variables and one dependent variable. So this is a multivariate equivalent of the post-test only control group design. Next, we have the pre-experimental designs. So if random assignment of subjects and laboratory-like control are not possible, it will be necessary for the researcher to use a pre-experimental designs. So we have here the examples of the pre-experimental designs. First, we have the one-shot case study. Second, we have the one-group pre-test post-test design. And lastly, we have the static group comparison. So let's have first the one-shot case study. So the one-shot case study, which can be diagrammed simply as X0, is an extremely weak design. Next, we have the one-group pre-test post-test design. So it represents a slight improvement over the one-shot case study because it incorporates a pre-test or one or more observation point. And lastly, we have the static group design. This design utilizes 2 groups rather than one, each of which is observed once. Quasi-experimental designs. So this is a type of experimental design which represents an improvement over pre-experimental designs, including those just considered. So it usually includes naturally occurring groups, but they often involve more than one group and typically have more observation points than do pre-experimental designs. So a quasi-experimental designs include the following examples. So first, we have the time series design. 2, we have the equivalent time samples designs. 3, we have the pre-test post-test non-equivalent control group design. And 4, we have the multiple time-lapse series design. So let's first discuss the time series design. So this design represents an extension of the one-group pre-test post-test design. While the equivalent time samples design is particularly useful where the effect of the experimental treatment is expected to be of transient or reversible character. So next, we have the pre-test post-test non-equivalent control group design. So this multiple group design has some of the features of the static group comparison and the one group pre-test post-test design. So as can be seen from the following diagram, it provides pre-test information and a comparison group, but the groups are not fully matched or randomly assigned and thus cannot be assumed to be equivalent. And next, we have also the multiple time series design. So it is the multiple group counterpart of the time series design. And lastly, we have also the ex post facto designs. It represents a weaker type of quasi-experimental design, and they are designed to stimulate real experimentation. Next, we have the web-based experiments. So the web-based or internet-based experiments are becoming more common, especially in some of the social sciences. So this technique allows researchers to collect large amounts of data from widely dispersed people and locations at minimal cost. So we have learned that experimental research is generally considered to be the most rigorous of the basic research methods. It is considered capable of supporting causal relationships, and it is able to do so primarily because, at least in the case of true experiments, it employs equivalent comparison groups, permits manipulation of the experimental variable, and controls alternative causes of the dependent variable. So that would be all. Thank you.